Welcome to Chapter 9. From this lecture, we are going to start the Object-Oriented Programming. Chapter 9 is for objects and classes. This lecture is on class definition and object creation. First, let's look at what is object-oriented programming. We have been involved with basic elementary programming, that's statement by statement, like working on the machine code or assembly code or basic program. That's just a statement by statement, and it is very tedious to do the programming over there. And then we use structural programming. It seems to be working fine, and then most of the tasks can be done by structural programming. Then why we need the object-oriented programming? Because there's a need. Since Windows start to be in use, object-oriented programming becomes so important because a lot of things need to be done in kind of parallel environment or pseudo-parallel environment. So we started to use this object-oriented programming. So what is object-oriented programming actually? It's treating program just by objects. And then say, to use a very simple concept, a person is an object. And then a person has some hand, eye, ear. You can hear something, you can watch something, you can do something. But two individual people will not follow a certain procedure that one do something and then the other follow him or go into a certain loop. It will not behave like that. On the contrary, these two people will have some interaction that each other have a certain event happening and the other one react, or one of them activate some event and the other participate. Something like that. And they could be happening mutually or very close intertwined. That's why we need the object-oriented programming. So after learning the preceding chapters, you are capable of solving many programming problems using structural programming, selection, loops, method, and array. However, these Java features are not sufficient to develop a graphical user interface and a large-scale software system. Suppose you want to develop a graphical user interface shown as below. How do you program it? You cannot follow one instruction, say I can only click OK, you cannot click cancel. You cannot do that. Say you can only click a button and you cannot click these radios. So that's why we need object-oriented programming. Object-oriented programming is more compatible with event-driven programming, more manageable for GUI components, more organized data method related to certain objects, replacing library, replacing the data record, and include the event loop, and enable thread execution control. So object-oriented programming sometimes also showed as OOP, and it involves programming using object. An object represents an entity in the real world that can be distinctly identified. For example, a student, a task, a circle, a button, and the event and long can be viewed as objects. An object has a unique identity, state, and behavior. The state of an object consists of a set of data fields, also known as properties, with their current variables. The behavior of an object is defined by a set of methods. So, say if we have a circle, it has some radius. There are some property like area, parameter. Then we can use some method get area or get parameter or set radius for a circle. So objects are individual circles, but we can have some abstraction so that we can describe this sort of object and using the same mathematical method or procedure to handle it. The collection of the methods and data definition to operate those individual objects is called a class. So an object has both state and behavior. The state defines the object, and the behavior defines what the object does. And this chart includes a description of the data field, that's the state, and the behavior, that's method. It's called UML, Unified Modeling Language. And the chart right here, including the template that we call the class, and the object right here, And they are data field, constructor for the method to construct an object, and methods that handle those events or behaviors. Classes. Classes are constructs that define objects of the same type, so I also call it templates. A Java class uses variables to define data fields and methods to define behaviors. Additionally, a class provides a special type of methods known as constructors, which are invoked to construct objects from the class. So right here, use a very simple example for circle. You have radius as data field. You have constructor that build a object for you. But sometimes you have some parameter radius, so you can set a radius. But sometimes you want to runtime to update it. So you allow two kinds of the constructor, one with parameter and the other one without. And then getArea is to get some property for this circle, such as the area. And example, we will use this simple circle as a test case for it. Let's look at the program. Right here is the definition of the simple circle. You can see the radius, and there are two constructors. One have no parameter. It default set the radius to be 1. The other one can accept your new radius and set it to the radius. And then getArea, get parameter, and set radius. Set radius, we call it a setter method. Get parameter and getArea, we call it a getter method. Getter method is to get data out. Setter method is to set a certain property of the class or object. And here is the main program to print out some information. Let's look at the program. Here as a result, use a different radius and provide different area. That's not important. Let's look at here. We have two classes. One is called tester class. One is data definition class. The tester class uses the data class. And right here for OJ, there's a dash arrow. That's for the use relationship. And we have been using this tester class many times. So that's the way we organize it. You can also put this class as a subclass for the tester. That's also fine. So please download this program and try on it. And take a look at how this class and object works. Thank you.